Already, we're starting our webinar with topic CANopen FD. My colleague will be holding the introductory part up to the slide 12 about so, and then I continue with the CANopen FD content. Okay, so then I would like to introduce myself in first. My name is Oscar Kaplu. I'm working for Canon Automation already for some time, a decade or so. I have a degree in electrical engineering, and as usual in Canon Automation, we have some activities which I support as well. We supervise, I supervise multiple special interest working groups at Canon Automation, which design CANopen specification, data specification for the very certain type of devices. I/O modules, applications like lift, drive control, simple sensor, and beside that, I'm also doing testing of these devices developed by our members. We have CANopen conformance testing, interoperability testing, and now also CANopen FD testing. So, which means this is our topic of today, CANopen FD. And I might also talk a word or two about the testing itself. So in the next slide, my colleague introduce yourself and start with the introduction. And after that, I'll take over and continue with the CANopen FD part. Please, Yao.
好的，大家好。那么呢，我是今天的翻译。我呢在 CA 任职呢技术小组的秘书。OK，next。那么呢，您现在看到的就是 CA 呢，我们坐落于德国的纽伦堡啊，然后我们在世界上呢只有这一个办公地点。OK。CA 的会员发展，您可以看到一个趋势。那么呢，从1992年会员协会成立以来呢，会员一直是增长的趋势呢。那么现在在今年，我们已经有700多家会员了。OK。CA 的几个重要的历史里程呢，那么在1994年的时候呢 ，CA 首先发布了301的这个CANopen的基本的通讯协议。那另外一个呢，就是关于今天的这个题目呢，就是 CANopen FD， 它的协议呢是首次发表于这个2017年，它的基本协议 CA 1301。OK。那么您现在看到的就是 CA 技术小组的一个基本分布情况。技术小组呢是由这个 CA 的技术委员会呢来组织和管理的。那么主要工作呢就是进行这个规范和应用记录的一个开发。然后呢，我们呢是在各个小组呢负责各个不同的题目。那么这个 CANopen FD 今天的小组呢就是设立在这个 IG CANopen FD 下面。OK。CA 呢，除了有技术小组之外，我们还有各种的市场小组。那么我们主要的任务呢，就是支持市场的开发，包括这个有联合的在展会上呢有展台啊，然后一些活动啊，还有一些会议啊，还会有一些相关的出版物。OK。那么我们呢，就是提供的服务呢，就是以 CA 的规范为中心，那么提供给这个系统设计人员和设备生产商呢，包括这个咨询、测试、产品指南，还有一些宣传册，然后我们的涉及的包括这个技术和市场范围呢，包括提供给您这个研讨会和技术杂志的一些服务。OK。您如果对我们的实时的这个更新的消息感兴趣的话呢，欢迎您订阅我们的这个 info mail， 它是一个月刊。那么我们的会员呢，还可以订阅我们的 member mail， member news， 然后会提供我们这个专门关于会员的一些每个月的一些相关的最新的信息。OK。那么加入 CA 的具体优势呢，就是如果您是产品开发商呢，那么最明显的优势呢，就是可以免费下载最新的和 现在正在开发中的 CA 的所有规范，包括所有的一些文件，然后呢可以参加才可以参加 CA 组织的这个 Knft 客户操作性测试，并且呢还可以以优惠的价格呢测试设备还可以免费获得 CANopen 的厂商 ID，并且呢我们还是会有这个优惠的价格来提供这个培训呢和一些活动的一些包括展会的一些参加的。OK。
So, thank you, Yao. This is the time where I'm taking over and my colleague relaxes a little bit, but we have prepared the slides in a manner that the most important slides where we have an opportunity. We'll put some short key message describing in short what the slide meant, what will be our actual message about this one. So then I start with our topic, CANopen FD webinar. This is a short overview of our basic CANopen FD capabilities. Before I start, just some introductory words. Ms. Yao has already described what is CANautomation, what activity we offer, what can we do for you. CANautomation has experience already more than 25 years. And it was started with a time when CAN was evolved, was developed by Bosch, used in automotive. And then industrial automation also become aware of advantages of using the universal bus system such as CAN. And then we came up into a play to provide product related, technical related information to cover this opportunity, since automotive has a very specific market and they couldn't simply share their knowledge with everybody else, since this is also their specific know-how. Okay. I start my slides with a brief introduction of classic CANopen. For those of you who are not aware of this, CANopen is CAN-based, could be at least CAN-based higher layer protocol, and CANopen itself is a more than this. It is not just a layer. It's also communication profile. It exists already several decades, and it is very useful and is used in various application fields, various markets. It is stable already for this long time, and you can purchase off-the-shelf devices, and with very little effort, you can design your network. Even if you develop those devices, CANopen devices, there is already a big market and also a technology update, a big technology support for this one, either from the developers or from the companies providing the devices, or from the side of CANautomation. And if you have questions, you could ask us. If we don't, if we're not able, because of technical complexity of the question, we have already contact to all our members. And if we cannot answer the question, we wire the question to our members. So the whole community will be involved in solving your problems. Well, yesterday, my colleague and actually our boss, Mr. Zitzman, presented update to CANopen FD in relation with already finished International CAN conference. Took place last week with very interesting presentations. I would give it a couple more words about this at the end of our webinar of today. And you can look into what was the topics of the ICC, this International CAN conference. You might be interested to get some update on it. You also provide information about CANopen FD, but there was the very recent information. Our webinar of today will be slightly little more basic for those of you who are looking into starting up with CANopen based market and wanted to do something a little bit more than CANopen itself. Classic CANopen, as we call it now, is not a CANopen FD, but it remains for now and will remain for some time, I think, for a long time as well, I think, because it's already used in various application areas, embedded control, not only device, but deep embedded control, where you cannot see from outside, can recognize what is inside of the system. There's this deeply embedded network in there, so it shall be working very efficiently and reliably to be used in such a in-deep network, embedded network. So, going on that from this point of view, you need to learn what is CANopen FD, why it is called CANopen FD and not CANopen, just with some additional functionality. Yeah, that would be a good idea actually, but we thought for the first, at first, it would be quite nice if you do this, or if we separate technologies, since they are not completely the same, and will help out to distinguish between them even with implementation. However, there is an opportunity to combine and operate both networks together. So where we start? We will start with data link layer, which is used in CANopen FD. This is CANFD. This is one of the three recently developed, one of the two recently developed new CAN protocols. There is also CAN-XL, but this is a very new one. It's still in development. CANFD is already available on the market. There are controller available, CAN controller, CANFD controllers, and the transceiver which transmit the message itself, which is suited for CANFD. CANFD has certain advantages over the classic CAN. Classic CAN, as you can see from this slide, in a base frame format, allows to send up to 8-byte payload, and it's used mostly for a short process-related data exchange, for the control messages for the network. It was much more sufficient. And as I said before, you can send by this means also short process messages such as pressure, temperature, position value, something like this, control word, and it fit into 64 bits. If you're familiar with CAN, you know the structure of the message. Covers for most important things and the reliability of the message itself. It has an error verification. It has data content verification, more or less. And what is also important, it allows, along with the CAN identifier, to select which message is going to be sent over the bus. Just to remind that CAN bus is a producer-consumer operation. Only one device can send the message, whatever it might be, and all the other devices just hearing for this message and check out if they are set up for evaluation of this message. So to overcome certain limitations, such as a relatively small payload, CANFD was introduced. It allows up to 8 times more data to transmit, 64 bytes. For that, the control field is extended, and it makes the use of reserved bits, previously controlled bits, to allow to verify or indicate number of data to transmit. So the basic structure of the message is not changed whatsoever, but the usage of certain reserved bits, especially for control field, is available now. So for those familiar with the structure, it will be easier to understand what CANFD offers and how to control and to use the controller and program the controller itself. Well, another certain advantage of that, it allows to transmit the data with a higher speed, especially the data field itself. It is not bounded like the CAN onto this bit verification. So every bit which is sent from the device has to be returned back and confirmed by the sending device and also by receiving devices. That limits, due to the topology-related structure and signal distribution, signal transmission-related things, is bounded to the bit rate, is bounded to the length of the network, so they are limited. The same applies partially to the CANFD. However, to overcome certain irregularities, and this one, the data transmission is not verified bit by bit, so theoretically the speed of data transmission phase can be so high as the transceiver allows. So what are the certain advantages of the CANFD really with the statistics data and measurement data? So as you see, if I have only payload of 8 bytes, similar like classic CAN, but I'll operate with a higher speed of CAN, it's just alone the higher speed allows me up to 1.5 faster than a classic CAN. If we also transmit the data using the full payload capability of the frame, then we have a 3 times bigger, for this certain example, 4 megabit, 3 times faster effective transmission rate of the data than a classic CAN. Although this for some, it will be slightly advantage because you're mostly, some of you may be mostly using payload itself, then it will be actually an interesting point to see how this data can be used in higher layer protocol, which define the data, how the data is represented, and how the data and advanced protocols, which can be based on the data link layer, can be used. Okay, so we start through CANopen FD. CANopen FD is CANFD-based application layer, and more of this is also communication profile. Incorporates the typical 3 layer of every communication, model system structure designed by ISO, the so-called open system interconnect, which every device have inside. But CANopen device doesn't have communication of human to human or human to machine. This is purely machine internal communication. This is the reason why we need only 3 layers. So the data link layer, physical layer for transmission, data link layer for representation of the structure itself, and application layer for designing of the data and standardization of the data that which is transmitted. Canon Automation made some efforts and released in this group, IG CANopen FD, released specification 1301. So we name it differently for CANopen FD. There is a specification 301 for CANopen, classic CANopen. So we leave it as it is. We're also developing this all two in parallel, but CANopen FD uses all advantages that payload of CANFD offers with itself. So it opens further possibilities we will learn from the next slides in regard of the application layer. What we can use, how can we use CANFD, how does it, what does it offer to us? In the first place, the bitrate is higher bitrate supported, and CANFD introduced bitrate switching. The bitrate switching is introduced, which you see in a previous slide. We have arbitration phase and a data phase. So just to turn the data, send the data with much higher speed and not relate to the bit-to-bit verification, bitwise verification. It also offers the possibility to distinguish between the messages on the bus. So there are certain bits, or certain bit actually in a CANFD frame, allowing you to not only to switch to the CANFD, but one of the bits allow you to distinguish between them when the bit rate switching takes place. This is in the middle of bitrate switching. And you also know from the arbitration in CANFD, you know which message is it CAN or CANFD message. This is also an important part. So, but go back to the bitrate. We have set in CANopen, it was already 8 bitrates defined, and then it is actually possible to use, not possible, this is a mandatory. So you have to, every device has to have at least one of these 8 bit rates. The situation is more complex in CANopen FD. You have 2 bit rates, arbitration bit rate, which doesn't goes above 1 megabit, and data bit rate, which is much higher than this. So they could be switched, maybe not switched. It could be only one bit rate, one same bit rate, higher bit rate used for arbitration and the data phase. That could be done also as well. But in this case, it will be much more difficult to do because there are several bit rates possible. But to optimize them for the transmission, the bit timing defined in the specification 1301 offers you an opportunity to select the bit rates you would like to have, bitrate pairs. To overcome certain limitations and increase the interoperability of the devices, not only 1, but 4 mandatory bit rates shall be supported in each device, which can be used by every CANopen FD devices. Can be recognized in all devices, and you can immediately, the communication can start immediately if this all bit rates are supported. The design of the network, the device and a network topology and a bit rate is not actually in a standard, in an actual standard for CAN, which includes also CANFD, this 11898 ISO. It doesn't include any recommendation how to design a system. So we at CANopen designed with the experts from automotive and other industries. We designed specification status 600, which you could purchase or become as a member of CANopen. It provides all recommendations for network design, bit timing, how to calculate the bit timing. All those things are already available. You can use them and so on. So then, Yao, could you look in the key message?
OK， 那么现在呢，总结来说呢，那么对于这个CANopen FD 的比特率呢，那就是说基本上来说就是每个CANopen设备都支持几个固定的标称和数据比特率对，那么以便呢可以立即的使用。
Okay. So what I already said, 1301 has already bit timing. You have to use, especially for the mandatory pairs, but there is an opportunity to do some optional, to design some optional bit rates that you have, and the bit timing for that is already available. The bit timing is only for 80 megahertz clock. CAN clock actually, and 40 megahertz clock data bit timing will be also introduced soon. Yao, please.
所以总结来说呢，就是1301的这个未定时呢，就是所以设备呢必须要支持列表中的 CANFD 的这个未定时的设置，那么以便呢可以立即的使用。
Thank you. So the bit timing, bit rates, you know about this. With introduction of CANopen FD in specification itself, we designed also a modern, designed into the modern way to represent the structure, the class diagram of the network itself. There is a structuring of field device, CAN device, and CANopen device. Where is it? Where you can find it? You can find it in specification, and you can recognize what to do in there. And especially for this slide is the meaning that there are certain structural differences between devices, and you know which devices actually resides as the software entity in a physical entity. So we introduced, of course, the certain bit rates which are mandatory, but the bit rate itself is not designed already in CANopen FD device, because it's another layer where you design the software. The bit rates are actually incorporated in CANFD device, so there you can set them up as well in this hierarchical structure. So, communication state machine defines how every CANopen device actually starts and go into operation whatsoever, and it is typically controlled by the master device, or like we call it in a modern way, this network manager, network management controller. Every CANopen device, as I said, has a communication state machine. It defines how it operates. And we have designed, or at least we have introduced the way which we have additional functionality in there, a more detailed functionality for you to better understand how to, if you design this, which parts have to be designed in there. Additionally, in contrast to CANopen, we have introduced also the master communication state machine. So it is incorporated already in the base diagram. So you know if you have a master, where it starts and how it relates in general into the whole communication state machine. So the key message, Yao, please.
所以总结来说呢，详细的Knft 有限状态自动机呢，可以帮助呢以便更好的了解目前的通讯状态。
Thank you. So the next couple slides are related to the protocols themselves. So we have, you see, communication state machine for CANopen FD. It has also an NMT controller inside, so you don't need to access another specification, but 1301 specification already defines how network management controller, what does it requires, and introduce its parameter, which is important in this case. So what are the protocols actually available in CANopen FD? The same as in classic CANopen, we have transport protocol to transmit the data, like process data object. It is limited, however, in classic CANopen with 8 byte. We have also configuration diagnostic protocols where you can access a point-to-point communication. The devices, each device as service data object, it has 3 basic protocols allowing different capability of data transmitting and receiving. The basic one, which allows only up to 4 bytes of data, and is actually control information is also available in frame itself. If you would like to download firmware or has a big chunk of data to download, for that reason, segmented, code normal, and block transfer is allowed. It does, in contrast to CAN or whatever CAN application layer, combines several CAN message into the larger block of data which are hanging together and designed in one protocol for the reason to transmit larger number of data. And has also, especially a block transfer, has also verification of the data content in there to a certain degree. There is also emergency protocol to indicate network-wide errors occurring in a standardized way. And of course, CANopen introduces network management. So to handle the whole network and allow you not only to design a simple devices, but you can actually manage the whole network using PLC or CNC, whatever it might be, by starting the whole network devices, downloading the firmware in there, checking out if the devices are available in the network, something like this. Also, error control protocols are available, such as heartbeat protocol, allowing in a manner of typical CAN communication, producer-consumer, to transmit the data, has no limitation from this reason whatsoever. And another one with a restricted protocol called remote transmission, node guarding. This is still used in CANopen, has its downside because it limits the reliability of data for a certain degree, and it should be avoided to the certain points. Well, CANopen FD actually does have very same. So to allow you to go from CANopen, if you have developed with that, or start through with CANopen FD straight, we have not changed that much in CANopen FD in contrast to CANopen. Because the reusability is a very important part, and migration is also very important to save the cost for the software implementation and so on. However, the payload allows you, payload of 64 bytes allows you to do some pretty amazing stuff. The process data object is now 8 bytes longer. The communication for configuration and diagnostics, like the STO, can be not only extended with additional protocols and not only covering of 64 bytes, but also allowing to think about, due to the number of payload, bytes in payload, to introduce some various new protocols which were not possible with classic CANopen, maybe due to limitation. It is already existing more than 20 years, not to reduce the interoperability of older devices. So now we have an opportunity to completely redesign communication design and diagnostic protocol, and we call it universal STO. In the next slides, we see first the PTO and then also what is made of this new universal STO protocol. As you can see, we kept in a typical way of designing USTO protocol. Like a USTO, it has the basic protocol expedited for up to 58 use bytes, actually data payload, and the remaining bytes are just controlling bytes. It has also larger protocol for larger chunk of data with 2 effective ways, segment and bulk transfer. We have also emergency protocol allowing to diagnose, make it a diagnostic in the network in a producer-consumer way. It is bigger than another one, is as the classic CAN ones, as a 20 bytes now, because it contains information which is much more useful and wasn't possible with the classic CAN whatsoever. The special protocols and network management is actually, they are actually shorter bytes in order to prevent high cost of re-implementation of this. They remain as they are not unchanged that much. However, CANFD doesn't use remote frame anymore, and thus every protocol in CANopen FD which used in classic CANopen remote frame is now disengaged, is not used anymore. That is why, for example, there is only heartbeat protocol and no guarding whatsoever. And other protocols, as you will see in next slides, and especially also in our advanced protocols, are no longer available. You have to come up with something different. So we do a few words about process data. This is actually the same, remain the same. It is typical structure, how you see the data, how you configure the data. For transmitting using PTO, you have up to 64 data bytes to transmit, and you transmit this in producer-consumer way. So 1 sense only are the wait, receive, and check out if they have to evaluate this data. However, due to certain limitations, it is no longer possible to evaluate the number of bytes exactly. Number of bytes for the frame. It was typically designed in data with a DLC code, data length code in CANFD data link layer, but due to only 4 bits given even in classic and for that, we have the number of bytes can uniquely distinguish up to 8 bytes. But for the much more above this, up to 64 bytes, starting with the 12 bytes, we cannot, starting with the 9th byte, we cannot afford ourselves. There is no values available in this case. So these values then are not numbered. They are coded in certain numbers, which allow the total payload, but it could be smaller than the number of bytes designed in data link layer, the data length code. So you have to consider this if you design it, so you cannot exactly predict how much really of real content, data content is inside of payload. That is to think about. PDO has communication, classic PDO, classic CANopen has communication mapping parameter. They remain absolutely the same. The only difference that there's only 1 byte is allowed to map into PDO. That leaves us with the very same structure of PDO communication mapping parameters. So you don't need to change a thing. The structure of the parameters remain the same. We have also 40 up to 64 objects, but the smallest of them is byteways. So we don't need to design implement PDO differently than a classic CANopen. The only thing is that we just cannot map a bit value inside of it.
所以呢 ，PDO 的映射参数呢，是与 CANopen 的这个映射参数呢是相同的呢，但是呢，它呢传输的呢会比 CANopen 数据中的要多。
Okay, thank you. So now we go to USDO. There are a couple more slides about this to give you some overview what USDO actually offers in this case. It has certain advantages over classic service data object. It allows not only unicast as a classic one, but multicast, so to many, or to broadcast to all, which certainly make it in competition to the process data object. So imagine that I could send 64 bytes by PDO or just 58 data bytes using only simple USDO transfer. This is gone in competition. If you consider, however, that we have a transfer, for example, a segmented and bulk transfer for a much larger chunk of data, such as firmware, or the large piece of data, like a string or something, or similar, then you could do this very effectively by this one, but not only just by designing the type of transfer. It is also possible to do this by the additional things like calling the parallel access, which means I can send several requests to the very same device. Not at once, of course, because Knft is also a scan is sequential one, but one by one, and I can clearly distinguish them with certain identification. And this means actually I could do in certain way at once, sending several requests and awaiting the device response, leaning back, and so on. It has an additional advantage that was not possible without a special gateway, and would require additional client-server communication. As you can see in this one, this is only default communication that was usually used, every CANopen device has default STO server. So I could address the device and can read parameters out of it. For additional information, if I need to configure this differently or get some data from different devices, I need to establish another channel. It will require some implementation of additional STO channel, and it is no longer necessary with this inherent routing capability and a special access available in there. Additionally, this inherent routing capability allows create a virtual networks within the network. So I can address several devices by one device or by many devices inside of one network, and address and send a very specific messages only to those inside and communicate with that within this specific virtual network, without involving other part of the network and keeping them outside. So it is allowing a network in a network without establishing additional pairs of client server. For that reason, additional information which is not present in Classic and the network ID is introduced.
那么呢，对于这个，所以呢，对于通信服务数据对象呢 ，USDO 来说呢，它是代替了这个 CANopen 通信协议中的这个 SDO。OK。
Thank you. So, how it is possible this inherent routing capabilities, parallel access, and whatsoever, no additional client server pairs as was in Classic CAN? It is designed by two things actually. First one, as you can see in the slide, the devices are addressed not by the server, the USDO, by STO server or USDO server in this case, by its node ID. So this is specific introduction of the device identification in CANopen and also in CANopen FD. So every device has a special number, code encoded in the CAN ID itself. The remaining part of the CAN ID is indicating the kind of protocol. Is this transport protocol, STO, USTO, PDO, USTO, or whatever it might be, network management protocol. This allows effectively to learn from the CAN ID what is the kind of protocol which actually in there. So the node ID part is using to address a very specific device, and especially in Classic STO, the node ID from the server, which is device which is addressed, was always have to be incorporated into calculation from the client. That imposed certain limitations. If I design another client pair or would that address the very same device, I have to establish another pair, implement another pair, either statically or dynamically to access this device otherwise. In CANopen FD, it is no longer necessary, since every device, either it's client or the server, it can handle it by itself because it is using its own node ID. This effectively renders the configuration obsolete, so I don't need actually also a parameter for that reason to combine, as it was in Classic CAN, to create the distinguishment between communication IDs in either direction. It is done straight in each device. So not only this one in USDO is interesting, the interesting point is that most configuration is put into the frame itself. So we have 64 bytes of data, so we could spare some bytes for introducing some additional advanced configuration options, leaving us to completely configure the USDO communication over its payload.
所以呢，对于呢USDO 服务来说呢，它的服务器和客户端的这个 CAN ID 的配置呢，是基于其自身的这个节点 ID。
Thank you. So then in next couple of slides, we'll look into what are these configurations, how is it configured in a frame, and what are the kinds of USDO are actually interesting in there and what can be used. So as you see, the frame is a little bit bigger, the structure is a little bit bigger as usually, as it was in classic CAN. So it is, of course, no. And the interesting another part is that CANopen USDO is not limited like is not restricted like the classic SDO to having the same size of the frame for request and response. This renders effectively bus traffic a little bit downsized, let's say, bus traffic. If I have response very shorter than than is usual. So it increases efficient payload, efficient communication over the bus using USDO. So the structure itself, the node ID decides each device sending the message or receiving the message, configures its address, adding the node ID itself. And the information where to go is no longer necessary because it is encoded already in destination address. This is byte 0. So the node ID of the server is already in there. In the first message where I have USDO download request as an example, and the node ID of the client is already encoded in the response message from the server. This information is actually encoded in, as you see, the value definition, as the value definition is encoded in there. Only the node ID 1 to 127, as was usually possible for the simple, for the maximum in a single CANopen network. The node ID 1, the device with node ID 1 up to 127 is available. The above with this value definition of 8-bit or byte value is reserved for multicast communication, and the 0 is reserved for broadcast. So by sending in broadcast, I send to multiple devices. If I have the larger CAN USDO protocol, which is used for firmware, I could download the firmware at once into all devices which shall receive this firmware. That's an advantage.
所以说呢，对于这个 USDO 服务的目的地寻址的这个功能来说呢，它可以通过 CAN ID 呢来识别这个协议的发送方。
Well, another thing is, of course, the command specifier has a second byte, so we'll go a little bit faster on this. You can find this all information in details in our specification 1301. I just give a brief overview of advantages, certain peculiarities that you have to know if you design your device. What is the USDO offering, and say. The command specifier was already used, or at least as a name itself, was used to identify different types of USDO communication, others request, response, download, is it the short transfer or the long transfer, whatsoever. It is already encoded, however, differently. In this case, is just indicating the all possibilities which are available without any specific data information was provided in STO, because the amount of the forward data communication configuration is so big that it wouldn't fit into this single byte. So this purpose of this is solely to indicate what kind of transfer it is. And if you encounter this information on the bus, along with the command specifier, you know exactly this is about the client communication, which downloads, for example, and requests for writing the data. So the parallel access I've mentioned before is actually used if I don't have or a need to set several accesses to the very same device, asking for various information, and I want to do this at once. How do I distinguish between the messages which the device returns back? To know this, we have introduced a session ID, which uniquely identifies each single request and corresponding response with the very same number. So I do know that all the communication goes on. I know exactly to which device, which message, which request was assigned, and which response it actually shall get. This is also very effective for diagnostic purposes. So do not have the key messages for this case because it is more of the technical ones requires to reading specifications, a very certain one. So additionally to this bytes, we have configuration information. We have, as usually in classic STO, also it is point-to-point communication, broadcast, whatever it might be. It is also needed to address where the data shall go, which parameter it shall read or write. And this information is provided in byte 3 to 5 as appendix and index. This is already known. This is what is not changed comparing to STO. Additionally, there are also data type. This is also diagnostic purpose and recognition purpose, that you know how much memory shall be reserved with receiving of this message, or if request message, how much data, how much memory shall be reserved for reception of this data. This is the reason for this data type indication in there. Okay, let me go back a little. Finally, the size itself is additional information, says how much bytes, how many bytes actually accompanied with this data type, so I can recognize and do the diagnostics. For example, that I pretty exactly know how much data is actually to expect in this case. And with data type, I know how large is the data. So, and finally, from the byte 8 to 63, I have the useful data, the payload actually itself. Sufficient for transmit pretty much everything, even a small string, limiting to 54 bytes. And you can see the return message is very small. It indicates a very essential and necessary information like destination address, the command specifier, which indicates this is response correctly, the session ID response shall come with, and as usually index and subindex to get you information. Next couple more slides, we see how this data, how this works actually. Sorry. An example of the segmented transfer. So for example, firmware, the segmented transfer uses one way to communicate the larger number of data, but it offers also confirmation for every piece of information it sends. I have a size that I know from this one, how much data to expect totally. And there is, except the session ID for each single message I transmit, I do have also counter, which counts which number of segment is actually to expect. So the returning message from the server indicates with the same counter, and I know pretty exactly this is the very same, considering we have the very same session ID. So I have no way of distinguishing in this case if my message is corresponding to this very specific piece of data. In contrast to expedited, I need this counter. So additional one, this is a bulk transfer, is more effective way, seemingly segmented, because I do not confirm every single chunk of data I sent, but I do this after the block of data combining of about 127 segments together. And then finally, I get a confirmation over those. If they are correct, then I could continue with the next 127 segments. And this transfer is comparing to segmented, could be also more timely effective. There is the routing communication I've mentioned previously, allowing pretty amazing things in combination with the parallel access and designing of the virtual networks within the network itself. It has certain identification of the device, how this should be in there, how do I address this device, and don't worry, there is no problem if the device doesn't support these capabilities. The value in this case shall be 0. So if the routing capability is not supported, the network ID, which introduced in every CANopen device, CANopen FD device, as of right now, is just indicating that the device has no awareness of the routing in there. Other devices can be used with the gateways or even without gateways and do transmit the data inside this one single network and creating kind of virtual network within the network. So in a second remote USDO upload request, as you can see below, you see the full extent. How do I do this? I do have network ID of the sender, node ID of the sender, and I have the information, node ID and network ID from my destination. And also, I do have this information about, of course, the value I would like to send. So the parameter itself. In depth, you can read this, or can look into slides of my colleague from yesterday. It will be downloaded onto our YouTube channel, the CANopen FD update. Now I would like to go through the overview of USDO. With these amazing capabilities of USDO, it's actually delivering pretty interesting features in there. You can design your network and design the communication, can design virtual networks within the networks, can transmit multiple messages to the very same devices, can establish multiple communication data channels, let's say, into one single device. or multiple other devices without configuring this with the multiple enormous effort within the PLC or even your configuration tool. So the monitoring of the network is also simplified by using a broadcast communication of USTO. That is all in all offers pretty amazing functionality, capabilities, which CANopen FD devices are capable of. But there are no many mandatory features in there. You have to look very carefully in specification 1301, as you could do this with also very limited capabilities, but still you have a CANopen FD device and having all the advantages of USTO offering in there. The very latest changes done to emergency message, we will talk in a couple more slides in there, and then we go straight to this general information about new other features CANopen FD brings with that. Same as a classic CANopen diagnostic using emergency is used in CANopen FD as well. It is more advanced than this, since some other features are involved, which you see in the next couple of slides. What remains the same is the error state machine, which is used in every device. Every CANopen device with only bit 0 of the mandatory object 1001 is the state machine, error state machine of the device. It indicates if this device is an error or is error-free. The other bits of this byte just indicate if additional class of errors occur at the same time. Based on this, all the same as in classic one, just to give you as a background, the emergency protocol is incorporated, as you know, from classic CANopen, this object, this parameter, this byte with an error state machine inside. This is error register byte, shown here red, orange. Additionally, error code, this EEC byte 4 to 5, indicates specific advanced information about the error itself. What is this? There is a table in 1301 which indicates this class of the error in detail. And device specific is actually former classic CANopen manufacturer specific bytes. So the bytes from 4 to 11 reflect exactly the emergency message as it was in classic CANopen. But there are some downsides of the classic CANopen emergency message. You wasn't aware, if you send the data, which device actually sends it, especially if you have several entities of the same device in one physical device, so-called logical device. And you don't know the real status of the device. If despite the error register, is it actually a warning, or is this a real error which requires some attention? For this reason, the status byte was introduced. Also, timestamp, as you can see, time is introduced to know when the emergencies occurred. Since emergency is also will differ as well between the various protocols, the specification number has to be introduced in there to know which kind of emergency, based on which specification, basic specification is actually introduced, on which specification device profile specifications actually involved in there, because there will be in the future also different version, previous, older, or maybe newer versions. You want to know emergency, which is used, which one profile version it is used of. So much about transport protocols and other nice things. We are closing to the finalizing our webinar. Now this is just a basic information. I would like to give you a couple more slides in there. All in all, CANopen FD is to start free. We do have some actually testing in there. We specify already test. There is still no test tool. Test plan is in the process of development, but the testing procedure to bridge between appearing of the test tool and the testing of the device, since the device testing is mandatory for CANopen FD, to know. We have a manual checking and this procedure is available. So we actually can in testing of CANopen FD device. As I said at the very beginning, 2017, we had a released specification, first version of specification. The second version is currently in work in progress for the basic CANopen FD specification, which you could implement on. There are profiles of various different devices supporting different kind of communication, different kind of functionalities such as position encoders, drive controllers, some various components, I/O modules, whatever it might be, which is already designed in CANopen FD. In CANopen is also the version is designed separately for CANopen FD. We're currently in a progress doing this as well. And you're welcome, if you design these ones, you're welcome to join us on that. So here we have tested already CANopen FD implementations. In earlier times was protocol stacks verification, the simple I/O module verification. How does it work? So it operates, and more of this is actually successful. Well, I've mentioned previously where it started, what is actually done. We had some demonstrators already on the exhibitions in there. And currently, CANFD controller transceiver as a data link layer, and physical layer is available. CANopen FD specifications available. There is nothing stands between you and the implementation CANopen FD. We just have to look into this and ask your clients, customers, maybe they would like to go to CANopen FD if for the very certain applications which are not covered with CANopen. The next slide is also what I already told in general. There are actually everything's from the hardware related base and also software related base are available. There are ready to use offshore protocol stacks available. There are companies offering services and integration of CANopen FD devices. There are also gateways for CANopen between CANopen and CANopen FD, allowing bridging between two technologies. And there will be a couple more slides where I would like to go into information overview of proceedings of the International Conference, which covers not only CANopen FD and classic CANopen and even CAN, but a new technology, CAN-based technology called CANxl, allowing you effectively to use Ethernet-based and even mapping between Ethernet and CANxl data, up to 10 megabit of the speed and data transfer of data payload of more than 2,000 bytes at once. So briefly overview what we have still to do. There were some new things we would like to do in the version 2. We want to increase the capability indication, to increase the data field, to indicate the data field, because data length code indicating how many bytes actually in a frame are no longer indicating how really what is the number of bytes, and that is a variable data field comes into. We have started already for time at the same time as the basic specification to design advanced specifications into there, advanced network management protocol, flying master, LSS services. Then we design test plan currently, and we have already finished designing device description, which is basically XML based. There is no longer text-based device description, and you have to come with XML. The bit timings will be introduced for 40 megabit on request from our members. And as I said previously, there are 600 specifications allowing you to design your topology and data link layer for this and a network in itself. There is also part 3 of specification 0.601-5 for physical layer specification. You have to know what occurs on physical layer with this communication, when the problems occur on a physical layer, how the signal distribution goes on, how to prevent the data disturbances in there, such things. And as I said, we are currently mounting and designing profiles for existing device profiles, mapping them onto CANopen FD technology as well. To summarize in briefly, higher layer protocol effect based on CANFT offers some certain capabilities. The controllers, one day CANFT controllers will be replacing CAN controllers, so earlier or later you have to consider this possibility to do. And CANopen FD, of course, offers, based with a new protocol, certain nice capabilities. Bridging between CANopen networks and CANopen FD allows you to communicate between them, and using routers and gateways in there. And also actually bridges, this is a wordplay like bridge and bridges. In this case, by bridging, I mean crossing between those. And there are actually bridges available on the data link layer to transmit straight the data from one network into another is also possible. You can contact us on this matter. Just ask the question. If you are working on certain technologies, we'll be able to help you out. Basically, it is all. I just want to give an overview of recent activities we had. This International CAN Conference, and the International CAN Conference was taking place last week, was held online, had a very nice, interesting presentations, going into deep with the new technologies, CAN-based technologies, and proceedings to this are available. You can order them from CAN Automation. So just an overview of our presentation were there. The first one, the several groups of presentations, we order them structurally related to a certain topic. Was the physical layer representation design of signal improvement and networks with higher speed rates and so on, was presented by Mr. Adamson from NXP. There is, of course, a new possibility for Knft design to make it very simplified version of it called Knft Lite, which you could look into this. The presentation of Mr. Reinig goes in deep into the content of this. How does it, or what does it offer to you, this Knft Lite presentation? So there are other physical layer introductions like those from Mr. Hell, going into deep on the hardware level, what is going on physical layer and how does it fit with the new technologies, new emerging CAN technologies. Also, the issue with signal quality was made as a presentation in there as a signal improvement, special transceivers offering you signal improvement over the during the bitrate switching, allowing you effectively to reduce the number of oscillations, cause they when they are in simple network without this1, the oscillations will continue and the time for bit sampling is reduced to very short interval, which with signal improvement actually is much bigger, allows very effective sampling of the bit. So another presentations was about layer setting services designed by presented by my colleague, Ms. Yao, which is present today. See it here in the webinar. We have a latest work draft, how to design a node ID for, how to identify, how to configure node ID in a device using software-based node ID assignment called LSS. There is a special version for CANopen FD, which is different in a certain aspect from the classic CANopen ones, and it is designed in specification 1305, which is short before states short before release. So there are presentations also about testing, since it's an important part in evaluation of the device capabilities and evaluation of the network functionality of each single device was presented in there. You're welcome to look into these presentations if you got the proceedings, get the proceedings. And other things were designed about CANopen FD, about migration path between CANopen FD, how gateways works, how this remote virtual networks operates in there. And also one interesting aspect is security communication. How does the network become secure even in data link layer? How the information also in data link layer gets more and more improved by this means, how to prevent unauthorized access or integration, unallowed integration of foreign devices into the network. Such topics were addressed also by these presentations. So, for your information, CAN Automation has some activities in this year. Hopefully the pandemic will allow us to go face-to-face or in-person meetings and to visit some internal, local, European exhibitions. For your information, if you want to hear some webinars, especially in your mother tongue, in Chinese language, we have some advanced for CANopen Lift and CANXL webinar with this new CAN-based technology will be held by the end of the year. So far, I could address your problems, wishes to us over the phone, email addresses, and you could contact us anyways in there.